In this video, I'm going to explain about principle of transmissibility. Before understanding principle of transmissibility, let's understand about line of action. So what is line of action? Line of action is nothing but an imaginary line, which is this line, which is drawn from point of application of force, like from here, like this. And this is imaginary line, which is kind of dotted line, and it will represent the application of force, point of application of force and the direction of force. So in this example, the force is applied on this point and its direction is like this. This is the direction of the force, and point of application of force is this. So this line will represent the point of application of force and the direction of force. That is why it is called line of action. Principle of transmissibility. Principle of transmissibility states that the force which is applied on a body can be moved or transferred along with the line of action. So a force can be transferred any point on the line of action. This is what principle of transmissibility says. For example, consider this example. Here a body is there. This is the body, and this body is observing a force which is applied on the body, which will try to move this body in this direction, because line of action and the direction of force is in this direction. So what will happen, this body will going to move in this direction, like this. Will be initially here, and it will be slowly moving like this, like this, like this, and it will be stopped here. So due to this force, this body will move from here to here. There will be a distance covered due to application of this force. Let us consider this distance as 10 centimeter. Now, what principle of transmissibility says, you can move this force and place this force along the application of this line or line of action anywhere you want. So I will be moving this force, and I will place this force like this or like this, anywhere on the line of action. I can put this here, here, anywhere on the line of action. So I am putting this on the other side of this box, like this. This is the same box, this is the same F1 force, but this time I will be applying this force at this point. Before that, I was applied this force at this point. Last time I applied force here, and this body is moved 10 centimeter. 10 centimeter. It has moved. Now what I am doing, I am applying the force on the same body and the same amount of force F1, but at this time I am changing the position of the force, but the line of action is same. So what I am doing, I am just moving the force along the line of action. Like the force was initially here, like this. What I am doing, I am removing this force from here, and I am putting this force here. Now, due to this force, this body again move in the direction of force, and guess what? The displacement due to this force will be same as 10 centimeter like before, because the same force we have applied and in the same direction, but we just change the point. But we are not change point anywhere but on the uh, line of action of this force. So whenever you apply a force on the line of action, then the result will not going to change. So we can apply force anywhere on the line of action. So we can remove force from anywhere and we can apply that force anywhere on the line of action of that force.